Good morning and happy Wednesday to you all. Today we are going to take some notes on how we classify numbers and what number falls under which classification. And then I've got a really fun little activity where you're going to be coloring a chart based on the number classification. So today isn't really anything too crazy hard. I think it's a fun little activity. So as we're talking about these multi-step equations, how we move numbers, how we solve for a variable, I wanted to make sure that you guys actually understood what each number was. Most of the numbers that you guys have been seeing in your multi-step equation problems have been just different integers, either a positive whole number or a positive negative number. Not a positive negative number, a positive fraction, a positive whole number, or a negative number. You guys haven't really seen any other crazy numbers, but as we go on further in math, there's going to be lots of different types of numbers. So I want you to have this page to always be able to refer back to on the different classifications of your numbers. So today won't be too long. You're welcome, a midweek break. But we are going to make a little classification table here by ourselves. We're going to draw it in. But first I want us to define each classification. So I'm going to color code my definitions with my chart that I'm going to make later, and you'll need 6 colors. Or you can just repeat a couple colors if you need to. I don't think I have. Here we go. I've got 6 colors now. Okay, the first classification that I want you to write down is going to be natural numbers. So I want you to write natural numbers. And the definition for natural numbers is whole numbers starting with 1. So if you don't know what a whole number is, it's a number that's not a fraction. So if you have 1 apple, you have a whole apple. If you have 2 cats, you have 2 whole cats. If you have half of a pie, that's not a whole pie. That's not, 1/2 would be a fraction. So it is whole numbers starting with 1. And the way that I remember this is natural numbers are numbers that you would naturally use in your day-to-day life. Just when you're, counting things, we don't count starting with 0. Obviously, we count with 1, 2, 3, 4, 5. Imagine teaching a small child their numbers. We start with 1 and we start counting. Whenever you're using things just in your day-to-day life, we typically start with 1. A whole number would be the next classification. And whole number includes natural numbers, but it has something extra that sets it apart from this. And it is whole numbers starting with 0. So natural numbers do not include 0. Whole numbers do. So whole numbers include natural numbers, but it also includes 0. So every classification that we start writing about will include everything before it. So whole numbers include natural numbers. It's just got some extra. The next one we're going to write down is integers. This is what you guys see a lot in math. Integers, those are positive or negative whole numbers. Okay, so when I'm talking about integers, this includes -4, -8, -10, 0, 1, 2, 5, 9. So integers does include zeros and does include all natural numbers as well. It's just got some extras. So every classification, we're getting more types of numbers. Natural is just 1 and up. Whole is 0 and up. Integers are all the negatives and then all the way up. So we just keep adding. The next one is called rational numbers. This color is kind of light. I apologize in advance. You can still see that, right? Okay, rational numbers. This is, I'm trying to make these definitions as short and simple as possible. Any number that can be written as a fraction or decimal that ends or repeats with pattern. So that's a bigger definition than we've had so far. And we're going to put some examples down below in our chart. But if integers are all of our negative and positive numbers, so -2, -8, -10, 0, 1, 5, 9, 12, rational numbers are kind of all those numbers in between. So all your fractions, 1/2, 1/8, 1/16, 1/100, I mean any fraction you can get to. And then if that fraction can be written as a decimal that ends or repeats, so a half would be 0.5, right? That's a decimal. A decimal that repeats would be one that's like 2.33333333, and that's represented with that line over that number. So we know it's the exact same repeating number, which means no matter what, you're just going to keep on getting the same number. Or the pattern could be, 2.14141414. It keeps repeating. But it is all of your positive numbers, all of your negative numbers, your 0, all your fractions, and all your decimals that either end or have a pattern. So those are rational. Those aren't too terribly scary. And then the next classification we have is called irrational numbers. Irrational numbers. Okay, and these are non-terminating, meaning they do not end, like 1.5 would be a decimal that ends, right? This is non-terminating, non-repeating decimals that cannot be written as a whole number or a fraction. Okay, and there are some numbers that when you're looking at it, you're like, there's no way I can make this a decimal that's actually going to end or a fraction. One quick thing about these fractions. All of your natural numbers, right? Those, well, even some of your integers too, not 0, but no, you could do 0 as well. Any number, any of these whole numbers can be made into fractions by just putting them over 1, right? 1 can be turned into a fraction by putting it over 1. 1 divided by 1 is still 1. You could do it to 0, but you're still going to get 0. Same with your negative numbers too, right? So I could have -2, and I could put it over a 1 and turn it into a fraction. You can turn any of your whole numbers into a fraction by putting them over 1. But if it's an irrational number, there's not going to be a way to turn it into a fraction. It's not a nice, clean, happy number. So what I want us to do now is make our chart so we can visualize what this looks like. So my camera is very touchy and it might fall over if I'm not careful. Let me pause this and get this situated. Okay, I got us situated. So what I want us to do now is draw a box. I think I'm going to use, I'll just use black. I don't want to use any of the colors I've already used. So I'm going to draw a box. You can make it as big or small as you want. There's no wrong way to draw a box. The bigger the better if you write big. Okay, so in our box, these are going to be real numbers. So right underneath it, write real numbers. And a real number is any number used to represent quantity. Right? So sometimes these real numbers are not fun, easy numbers, and that's where you get into the irrational ones. Sometimes these real numbers are nice and easy to work with. But real numbers basically include everything. So that's our box, right? Real numbers are our box. Everything in here is real. We can see it. Even if it's not a clean number, it's there. It's not imaginary. Some of them just aren't very nice. So over here, we're going to make our circles. So we're going to start with natural numbers, our first definition. I like to make my circles kind of grow off of each other, but if you want to start in the dead middle and put your first circle here and then go around the circles like this, you can. But I'm going to make mine kind of like bubbled up and keep going bigger and bigger. So the first one is, we'll do it here. Natural numbers. Now remember, we talked about this up top. These are the ones that we used in day-to-day life. So we're going to start with like 1, 2, 3, so on and so forth. Those are the easy numbers that we like. I'm going to draw my little bubble like so. Natural numbers. The next is whole numbers, right? So whole numbers. And these are the ones that we said included 0. So you have 0, 1, 2, 3, so on and so forth. Whole numbers include natural numbers, but they also include more. So I'm going to put it over natural numbers. So whole numbers are talking about natural numbers, but remember we added something new this time, zeros. I smeared my dots. All right, the next one is integers. So I'm going to write that up here. And those are the ones that include negative and positive whole numbers. You guys have seen a lot of these. Right, so it's going, actually I'm going to do 3 to 3. Right, negative and positive whole numbers. Draw your circle around that. The next one is rational numbers. These are the ones that are any number that can be written as a fraction or a decimal that ends, or the decimal can repeat. So again, we're still looking at nice numbers. These just typically scare us a little bit more. So up here I'm going to write rational numbers. And these are numbers like your negatives, -4, -2. Again, this is the one that's hard to see, this color, I'm sorry. It includes your 0. It could have repeating decimals, so like 2.33 repeating, right? It could have just decimals that terminate, 0.10. It can be fractions, anything that can be written as a fraction. So those are your rational numbers, and those are your examples. I'm going to put a circle around that because rational numbers include integers, they include whole numbers, and they include natural numbers. If you want to put like 3 right here, that's a natural number. So these actually include all of these classifications. So put your circle around them. There we go. So within real numbers, you have smaller and smaller classifications. Now over here to the side is our sweet little irrational numbers. I shouldn't say sweet. They're not very nice. So over here we're going to write irrational numbers. Here's some examples. You've got decimals that never end. 3.1415, and it goes on and on and on. Also known as pi, right? It's an irrational number. The square root of 17, that's not going to give you a number that's, nope. So any square root that doesn't have a perfect answer or a number that ends, it just keeps going on and on and on, those would be irrational numbers. 2.71828, I'm pretty sure that's E. Again, a number that it never ends. The negative square root of 11, also irrational. So these are numbers that they're real, right? We can see them. They're not represented like imaginary numbers. They're just not pretty at all. And they're very complicated. But they are real numbers, but they're irrational. So you can put these in their own weird oval, right? So all of these types of numbers fit in the real number classification. So now that you know what each number is, your assignment for today, let me tell you what that is. Okay, your assignment is called Color by Classifying. So you've got this big chart, and hopefully you can print this off and color on it. If not, you can just make a grid on some regular paper and just color the squares that match up with the numbers you're seeing. So I can just see the colors matching up. You don't have to write in all the numbers, but just color the blocks the way they should. Or you can do it on your desktop and kind of like edit the paper and color over it and highlight each area. Nonetheless, what you're going to do is color in each box based on the classification of that number. So as you can see, you've got decimals that end, you've got fractions, you've got negative square roots. Hint, hint, that's not good. That's the yucky, messy number. You've got repeating decimals, decimals that don't have a pattern but just go on forever and ever, right? So remember these that don't have a pattern and go on forever and ever, and these negative square roots. Remember right here what those remind us of, right? So what you're going to do is color them based on the key down here at the bottom. So you'll color in the boxes black if it's just a number that's not real. If it is a real irrational number, okay, it'll be yellow. Sorry. If it's a real irrational number, it'll be yellow. If it is a real rational number, you'll color it blue. And if it is a real rational number, but it is an integer, it is green. So remember, real rational numbers, if we look here, real is everything in this box, okay? If it is a real rational number, it can be any of these things underneath it. Real rational numbers hold all of this. So if it is a natural number or a whole number or an integer, it falls within real rational numbers. The only thing that is not a real number would be imaginary numbers. And so, like I said, we didn't really get into that in our notes, but your negatives within a square root is an imaginary number. So we don't like those. If the black is confusing to you, the numbers that are not real, that's not really super important at y'all's level. It is, but not for these notes. Then don't worry about the black. Let's just do yellow, blue, and green. So yellow would be your irrational numbers. Blue would be your real rational, like I just showed you. And green would be real rational numbers that are integers. So from this classification down, you would color green. So if it's not fitting within these three, then it's going to fit within rational, or maybe it's irrational. So you just got to make sure that you understand the classifications. You're looking at blue, green, yellow, and feel free to color in the imaginary numbers black. If you need to look up some things online to help you with this a little bit more, you can, but that is your assignment for today. So you're just coloring the blocks based on the number classification that you see. Okay, so that's it for today. I will give you one quick hint. If you've made it to the end of this video, I'll tell you all the ones that are black because, again, I feel like that might be difficult for you guys because we're not really talking about non-real numbers, just classifying all real numbers. Anytime you have a negative within a square root, it's not a real number. And then anytime you have any true number divided by 0, you can't divide something by 0. So anything divided by 0 or anything with a negative in the square root, those are going to be your non-real numbers. So those will be black. So if you've made it this far, there's your hint. If you didn't watch this video, you're probably going to struggle with that part. But my main goal for this is I want you guys to understand what are your rational numbers, what are your integers, and what are your irrational numbers. So remember, that's blue, green, and yellow. Color those, submit those, and that way I can take your attendance for today. And again, you have until Sunday to fully submit your work. Thanks, guys, and good luck.